Hey everybody, in this lesson video, I'm going to talk about area with coordinates, and we just had a lesson about perimeter, which is the distance around the outside edge of a figure. Area is the space inside, and there are some different area formulas for different basic shapes. So let's write down the area formulas that you should be familiar with at this point. All right, so we're going to start with triangles. The three-sided polygon. So triangles, their area, or A is often the letter we use for area. It is 1/2 times the base times the height. 1/2 base times height, or base times height divided by 2 is another way you can see that. And again, this is 1/2 times the base times the height of the triangle. Now I'm going to draw a triangle here so we can talk about what the height is. So the base could be any side. So here is a base, B. And the height is the perpendicular vertical distance from that base up to the opposite point. So here is the height, kind of, need to scooch it over just a tiny bit, of our triangle. So this distance forms a right angle with the base, and that is our height. And again, the area is 1/2 times the base times the height for a triangle. Quadrilaterals, we have a couple different types of those. Quadrilaterals. Now, in general, for a quadrilateral, area is just base times height, quadrilaterals, but it kind of has some variations to it depending on the type of quadrilateral. So first, let's talk about parallelograms. I'm going to do this one in this color. So in a parallelogram, we have two sets of opposite sides that are parallel, and the area is simply base times height. Base times height. Let's draw a parallelogram, kind of like a slanted rectangle. So here is my base. And then the height again is that perpendicular distance from the base up to the opposite side. So there's our height. I could also create a height going like this. This is the same distance as our height, but then I'd have to extend the base out to meet that height. So parallelograms in general, base times height. Now we can get even more specific. So we have rectangles, a certain type of parallelogram. In the area of a rectangle, when you first start learning about area of a rectangle, you are often told it is length times width, which is the same thing as base times height. So again, this is length times width, or base times height. Let's draw a rectangle now. Rectangle and length. Here could be the length, which notice this could also be the base. And then the other side, right, the shorter side, which we would call the width, that is also the height because that's a right angle. So this is the same thing. That is our width or the height of the rectangle, which is also a parallelogram. All right. Another type of parallelogram that you should know the area formula for is a square. write that over here. Squares. In a square, all four sides are the same. I'm gonna write the area formula first. So area is just the side length times the side length, side times side, or side squared. So that is the side squared, hence the name square. So here is a square. I will take this side length and multiply it times itself, because that is essentially the base times the height, because this is a right angle. Side times side, or side squared. All right. Now these are all parallelograms. There are rhombuses too, but that is a kind of more complicated formula that you do not need to know at this point. The other type of quadrilateral that we have that I left out is a trapezoid. So I'm going to write that up here. Trapezoids are not parallelograms because only one set of the sides are parallel to each other. And the area formula for a trapezoid, instead of just base times height, the area is the two bases added together. So base 1 plus base 2 times the height divided by 2. So let's draw a picture for this. So here are the two bases. And then I just need to have two lines connecting those two bases. Oh my gosh. I can't win. I just can't win. I just want it to be a perfect straight line. There we go. So here is one of our bases. I'll label this base 1. And here's our second base. We will label that base 2. Essentially, you're finding the average of these bases, right? Add them together, divide by 2, and then you multiply that times your height. And that's the area of your trapezoid. Okay. The other type of shape that I want to talk about are circles. So circles are always defined based on their center and radius. So let's just actually draw a circle first. Here's my circle. I'm going to move it down just a little bit. And here's the center. And the radius is the distance from the center to the outside edge. So the area of a circle is always pi times the radius squared. So that's the area. Another important thing that you need to know for circles is the circumference, which is really the distance around the outside edge. So circumference, that's like the perimeter of a circle, really. And that is equal to 2 times pi times the radius. So again, r is the radius. Now, something else that's kind of important in the keynote is that there are shapes that are made up of multiple basic shapes, and that is what we call a composite shape. So composite shapes are made up of 2 or more basic shapes. So if I'm finding the area of a composite shape, I can separate it into these basic shapes that it's made up of and then add them together, or maybe sometimes even subtract. So let's see, I'm going to draw 2 different types of composite shapes. I'm going to draw one that looks something like this, and I'm not going to worry about having it be perfect. So here is a composite shape, which looks like an arrow. And really, this is made up of a rectangle and a triangle. So if I can find the area of the rectangle and add that on to the area of the triangle, then I have the entire shape. Altogether, the area of the whole arrow. Another type of composite shape may be looks something like this. Pretend that all of these lines are straight. So this is almost a complete rectangle, but we're missing this almost smaller inside rectangle. So missing smaller rectangle. So to find the area of this, the area would be the bigger rectangle, subtract away the smaller rectangle. All right, let's do one example together in this video. I don't need to number it, it's just one example. A blueprint of a triangular platform is plotted with coordinates. Zoom. A, which is the point 2, 2, B, which is 6, 2, and C, which is 6, 5. If one unit, this is the U, if one unit, let me just erase it. Represents 3 feet. Find the area of the platform. In square feet. All right. And to do this, we're going to need to actually kind of get a visual of this. And I notice all of these coordinates have positives, right? No negatives involved. So I actually just need the first quadrant. So I'm going to create my X and Y axes. And it looks like the largest number I'm going to need is 6. So I'm just going to go up to 6 on both. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here's 6, which makes this 4, and this 2, 2, 4, 6. All right. Point A is at 2, 2. So over to 2 and then up to 2. There is point A. We have point B, which is 6, 2. So I'm going to go over to 6 and up to 2. And then we have C, which is at 6, 5. So over to 6 and up to 5. And I can draw my triangle, which points B and C have the same X value, which is 6, right? This is the point 6, 2 for B, and C is 6, 5. So this is a vertical line, whereas A has a height of 2 and an X value of 2. This is the point 2, 2. So this is a horizontal line and a vertical line, which tells me that this is a right angle here. So this is a right triangle, which means if I find the base, this is the base, and then I could represent this length of the triangle as our height. So the height between 2 and 5, that is a height of 3 units, going from 2 up to 5. And if 1 unit is 3 feet, I need to take this 3 units and multiply it times 3. So this is really 9 feet. And looking now at the base of this, the base is between 2 and 6 because it's horizontal. I need to compare the X values. So that is 4 units. So the base is 4 units. So now, considering that that needs to be converted into feet, this is 4 times 3, or 12 feet, because 1 unit is 3 feet. So altogether, the area of this triangle, I'm gonna write that up here. The area of a triangle is always 1/2 times your base times your height, 1/2 base times height, or even base times height divided by 2. And we have our base, we have our height. Our height again was 9, and our base was 12. So this is 1/2 times our base, which was 12, times our height, which was 9. And I actually can combine 1/2 and 12. I should say multiply 1/2 times 12 to give me 6 times 9, which is 54. And since we converted this all to feet, this is 54 square feet. You'll notice I needed to convert each length, the base and the height, into feet separately. If I multiplied 3 times 4, base times height, and then just multiply that times 1/2, that would give me 6 as an area in units. And that multiplied times 3 does not give me 54. So when you're working with area and you have some conversion factor, you need to convert the side lengths separately from units to feet, or units to whatever 1 unit is worth. Do not save that until the end. All right, please let me know what questions you have, and I look forward to seeing you soon.